Hey everyone, and welcome. Today, we are diving deep into a really cool question. How can we use the data we have right now to predict what's going to happen tomorrow? We're going to break down a super powerful tool that helps turn all that uncertainty into some seriously useful insights.
I mean, really think about it. How does a company figure out the perfect price for a used phone? Or how do they know which of their ad campaigns are actually making the cash register ring? These aren't just wild guesses, you know? They're actually calculated predictions, all based on understanding how different pieces of information relate to each other.
And the secret sauce, the engine behind so many of these answers, is a technique called multiple linear regression. Yeah, I know, it sounds a little intimidating, but trust me, we're going to show you how it's actually a really elegant and, believe it or not, intuitive way to connect the dots in your data. So, let's jump right in.
All right, so what in the world is multiple linear regression? Let's get into it. And to really get our heads around how we can look at many different factors at once, it actually helps to start by looking at a simpler version that only uses one. Okay, right here, this is the key difference. Simple regression, it's a great starting point. It can totally show you a link between, say, studying more hours and getting a better exam score. But real life is way more complicated, isn't it? Multiple regression is what lets us build a much richer, more realistic picture by adding in more factors, like, say, how many practice exams you also took.
So here's the official textbook definition. At its heart, multiple linear regression, or MLR, is all about using several inputs, we call them explanatory variables, to predict one single output, the response variable. It's really about understanding how a whole team of factors works together to create one specific result.
Now, the formula itself, yeah, it can look a little scary with all those Greek letters. But I want you to completely forget about that and instead think of it just like a recipe for making a prediction.
So let's break down this recipe. Y is the final dish. It's the outcome we're trying to predict. The X's, well, those are our ingredients, all the different factors we're putting into the mix. The beta symbols, now these are the most important part. They're the amounts in the recipe, telling us the exact impact of each ingredient. And that little epsilon guy at the end, that's just the recipe's way of saying, hey, no prediction is ever going to be perfect. It's that small, unavoidable difference between our prediction and what happens in the real world.
All right, enough with the theory. Let's see this recipe in action, because that's where it really clicks. We're going to make this super real with a case study. We are going to build a model to predict the price of a used phone.
So, our goal, our Y variable, is the used price. Simple enough. And what are the ingredients, our X variables, that we're going to use to predict it? Well, we're picking three. The phone's original price back when it was new, its age in months, and its storage size in gigabytes. Seems pretty logical, right?
Okay, so we took a bunch of data for 150 used phones. We fed it into our statistical program, and now it's time to decode what it spit out. This is where the story hidden in the numbers really comes to life.
And here it is. This is our secret recipe. This equation is the custom-built formula for predicting a phone's price, based specifically on our data. Every single number you see here, which we call a coefficient, tells us exactly how much each one of our ingredients matters. But how good is this recipe? I mean, really, we can measure that with something called R-squared, which is basically an accuracy score for our model. And in this case, it's 98.5%. That is absolutely incredible. It means that nearly all of the difference we see in used phone prices, a whopping 98.5% of it, can be explained by just our three ingredients. This tells us we have a really powerful model on our hands.
So this table breaks down what those numbers in our recipe actually mean in plain English. Original price is obviously the biggest driver here. For every $100 the phone costs brand new, its resale value holds on to about 61 of those dollars. Age, just like we'd expect, hurts the value, knocking off about 20 cents every single month. And storage? It adds a little bit of a premium. The key thing here is that we can now put an exact number on the impact of each factor all by itself.
So we've got this awesome model. Now for the really fun part. Let's actually put it to work and make a real prediction.
Let's imagine a customer brings in a phone. It's 2 years old, it originally cost $800 and has 256 gigs of storage. Instead of just shrugging and guessing what it's worth, we can now calculate it precisely.
And the process is so simple. We just take our recipe, we plug in the specific numbers for this particular phone, and then we just do the math.
And there you have it. The model predicts a fair resale price of $494.04. No guesswork, no haggling, just a solid data-driven answer. This right here is the power of predictive analytics in action.
Okay, pricing used phones is a really clear example, but let's zoom out for a second. Why is this tool so incredibly important across so many different fields?
Now, before we go too far, it's important to know this tool has a few rules of the road for it to work properly. We call them assumptions. It really relies on the relationship between your ingredients and your outcome being a straight line, more or less. And those little prediction arrows we talked about, they need to be independent and kind of random. Basically, following these rules makes sure our model is finding a real pattern and isn't just getting tricked by random noise in the data. The applications for this are they're almost endless. Seriously, the very same logic we just used to price a phone is used in finance to figure out what drives a stock's price, or in economics to understand how things like interest rates and inflation affect the entire market.
When you boil it all down, it really comes back to this one simple but powerful goal. It's about finding and modeling that straight-line relationship between a whole group of inputs and one single important outcome. So, the next time you hear about some company making a data-driven decision or using a predictive model, I want you to remember this. Behind all the fancy algorithms and the talk of big data, there's often this beautifully simple and elegant idea. Just understanding how multiple things work together to shape the world around us. And that is multiple linear regression. It's a tool that turns messy data into a clear recipe for prediction. So I'll just leave you with this question. Now that you know the basics of how it works, what's something you would want to predict? Thanks for joining me.